Hello, maurieo! In this video I'm going to explain about prism constants. But first let's have a look at a few prisms. Prisms come in many shapes and sizes and forms. Here's a single prism on a tribrac with a backing target there to make it visible at long distances. This one over here, again a single prism, just the prism. Most of these prisms will fit or have some sort of mounting system on here, usually either the Leica bayonet fitting or the 3/8 Whitworth screw in fitting that enable them to fit in some way or another on a pole, prism pole, or a tribrac, or various holders and things like that. Here we have a whole range of different Leica prisms. Here's just a single prism here. This is the H1i Prism, which relates back to the old days when the EDM was mounted on top of the theodolite, so you were looking through the theodolite to this point here for your target height, but measuring to a point slightly above it, the EDM being on top of the telescope. And here we have a single prism with a backing target, and the Leica 360 degree prism. Just a single prism here with a backing target. This one here is a small prism, usually known as a peanut prism. They just usually have a small spike or point in here. They can be carried in the pocket. Small leveling bubble here, very close to the ground, so they enable quite accurate movement without too much loss of accuracy due to verticality issues. And here we have a prism, single prism on a tripod over a mark. It appears there that it's got a Leica system that it's sitting on there. One of the I have one of these myself in my kit. It's got a plate bubble in round about here, so it enables quite accurate leveling of the equipment over the mark. Getting the pole and prism vertically over the mark of paramount importance. If we don't get things over the mark, buildings get built in the wrong place, errors get made, and it can become very costly for whoever makes the mistake of not having their material maintained so that it is vertically over the mark, or plumbing over the wrong mark, or mistakenly plumbing over something that looks like the mark but wasn't in fact the mark. But there's a small roundup on prisms, but we're here to explain prism constants, so we'll just have a look at what I've got to say about prism constants. And here we are. I've got a small diagram, very diagrammatic, showing a prism. Now the prism here is in red, as you can see, and the passage of light through the prism, of the wave or the pulse or whatever your EDM is using to measure, tends to come into the prism, goes across the prism and back out, and of course measures the phase difference or whatever to determine the distance. Now the actual effective or center of the prism, of course, is out here for a number of reasons, because the refractive properties of glass slow down the carrier wave. This helps to obviously make the effective center of the prism further out here. So here we have our effective center of the prism, and here we have the actual plumbing point, or this is the point that's over the mark. So the prism constant, which sort of relates to the passage of the light through the prism and the fact that it slows down as it goes through the prism, making the effective center of the prism here, but the actual plumbed point of the prism here. The prism constant is this distance between the plumbing point and the effective center of the prism, and that is why we have these prism constants. Now typically they're sort of between 30 and 40 millimeters, that is. I should make these millimeters. Okay, and we'll turn the grid off as well. Typically 30 to 40 millimeters, but they can be 0 depending on how the prism is configured. And some prisms allow for a configuration of -30, particularly the peanut prisms. By putting them or configuring them differently in the holder, we can have a configuration of 0 or -30. Now, the prism constants are usually applied in the instrument, so we have the ability to key the prism constant into the instrument, and it's important that we have that done correctly. If it's ignored, if the prism constant is ignored or implied incorrectly, it's a systematic error. It cannot be corrected by any particular procedure in the field. It's imperative that you get this right, because there's no way of correcting it, and it can be quite difficult to detect. A lot of people just use prisms with one particular prism constant. However, this is not always possible, so we must remember not only to change to the correct prism constant, but to change back again when we're using other prisms, particularly when we are using the the reflective capabilities, where we don't need to have a reflectorless measurement, where we don't need to have a prism at all. We must be very careful to set the prism constant to 0. So there you have it, prism constants, possibly related to the fact that the refractive index of glass slows the carrier wave down, and therefore making the effective centre of the prism further out from the back of the prism than the plumbing point, or the point that the prism is the point of the prism that's plumbed over the mark.